Okay. All right. So I'm gonna guess what I'm gonna do this time. This time I'm gonna keep this the way it is because if I don't, it's gonna give me a warning, and this warning is rather annoying. So just pretend that I don't have this part. We don't have to talk about this. I'm just gonna keep it. And here, um, let me just print something. Hello. Make sure that I'm not gonna get the warning. Yeah, it's good. There's no warning here. So, of course, I do need this backslash n. Okay. All right. So I want to talk about functions, and main is a function, and this int is a data type. And this data type is really the data type of the thing that this function returns. So in this case, main returns an integer. That's why we have an int here. I can create another function. I can create, as many functions as I want. We're going to do that in C, and we're going to do that in MIPS. So let's say I want to start with a simple function. So a function that doesn't return anything. And this function is just going to print welcome. So notice that it's void. So it doesn't return anything. And notice also that it doesn't contain anything here, which means that I'm not passing anything to it. And here I can print welcome to CSCI 250 \n printf. This is a really good fun course \n printf. I hope you enjoy it \n. So this is a function. Now, of course, for this function to execute, I do need to call it. So if I hit play, only hello world is going to be printed. And that's because I haven't called print welcome. Oh, this is going to, can I do this? Oh, it's going to keep showing. That's okay. That is all right. Okay. So for me to call this one, simply I would have to, call it by essentially saying print welcome, like that. So if I do print welcome, the execution is going to go here. We're going to do those 3 lines, and then we're going to continue here, and then we're going to return, which will quit the program. This return is going to quit the program because at the end of main, that's really the end of the program. So if I hit play, you will see that it printed this, which is that. It printed this. This is really fun, which is here. And here, I hope you enjoy it. And that's here. And then it printed hello world. Of course, I can print the function again. I could. I mean, in this case, it's not going to make sense because you don't want to print this twice. But the point of having functions is because we want to call it multiple times. In fact, I don't want to say that it's always the case, but typically we have functions because we want to call those functions multiple times. And that's not necessarily always the case, but it's pretty much always the case. So almost always the case. So you can see here it printed through those 3 lines, and then it printed those 3 lines, and then it printed hello world. So let's make this function kind of more interesting. Well, maybe I should just create another function. Let's create another function that returns a value and that adds 2 values. So I'm going to say add 2. And because it adds 2 values, ideally those values would be sent to it. That's at least that's what you would think would happen. And that's what we're going to do. And because of that, we do want to define kind of 2 parameters here. And those parameters are going to be essentially variables that will accept values that you send from the caller. whether the caller is here or the caller is here. Whomever is going to call at 2 needs to send 2 values that will be assigned to the 2 variables, which are called parameters. So here I'm going to say int num1, int num2. So right now, this is a function. It returns an integer, and it accepts 2 values. So if I want to call this function, if I want to say add 2, I have to give it 2 values, something like maybe 10 and 20. And when this function executes, when this function call executes, 10 is going to be assigned to num, and 20 is going to be assigned to num2. 10 is going to be assigned to num1, 20 is going to be assigned to num2. And inside this function body, I can use these 2 parameters. I can say, for example, printf the value of num1 is %d \n comma num1. And I can say printf the value of num2 is %d \n comma num2. And because this function returns something, I probably should return something. I'm going to say just return num1 plus num2, which is really what you would think this function is going to do because it's called add2. So what's going to happen here, and if you want to, I'm going to debug. So I haven't debugged before. I'm going to show you how I'm going to debug. I can add a breakpoint here. And when I add a breakpoint here, the execution will essentially halt or pause here. So if I hit play, the execution is going to pause here. And then I can go inside this function. So one thing that I can do is I can add another breakpoint here, and I can say continue. When I have another breakpoint here and I say continue, essentially what that means, continue executing lines until you get to the next breakpoint. And that would be this one, because we haven't gotten into add2 yet. So I'm going to do that, and you can see the execution kind of halted here. Now I can hover over num1, and you can see it says 10. And I can hover over num2, and you can see it says 20. Of course, the reason this one says 10, the reason this one says 20 is because I have 10 here, which goes to the first variable, the first parameter. And I have this 20, which goes to the second parameter. And of course, when I print this one, I can go one line by clicking here. You can see it's going to print the value of num1 is 10. I can go another line, and I can say the value of num2 is 20. And this return is going to essentially add 10 to 20. So that's going to give me 30. And 30 is going to be returned to the caller. And that's it. Let me continue here. Now, you notice something here. Let me actually comment these 2. We don't need that. And I'm going to hit play. Let me comment this one as well. Let me hit play again. You will notice that 30, the value 30, which is really 10 plus 20, was not added. This was not added. Anybody knows why it wasn't added? Like, how can we add it? What do we need to change here so that 30 is added? 30 is printed, excuse me. What do we need to do? Tell it to print the sum. Okay. Where do we do that? Add parentheses or define data types? Adding parentheses is not going to help. Adding parentheses here is not going to help. Or define data types. Not sure what that means. Okay, well, let me tell you something here. When you call a function, printf statement in the function, like which function here, this function, you can do that, but typically that's not what happens. Typically, when you have a function that adds 2, that function is simply going to add the 2. And when you call that function, essentially what's happening is, you see this highlighted section? This highlighted section will be replaced with the value that's being returned, and then you can print this, or you can assign it to a variable, then print it. Yeah, exactly. You're typically printing this, or maybe you're assigning this to a variable, then you're printing it. That's kind of typically what happens. So you can say int result equals to that, maybe. And then you can say print if the result is %d \n comma result, like that. So if you do this, then it's going to print the result is 30. So again, when you call a function, this function call will be replaced with the value that's being returned. That's how functions work. So this essentially highlighted value will be replaced with 30 in this case, because I'm sending 10 and 20, and 30 is being assigned to result, and that's what I'm printing. Okay, let's do another example. Let me do return here. What I can do is I can say my num1 is equal to, maybe 20. My num2 is equal to, 50. And I can say add to my num1. Oops, I didn't say int here. I should say int, of course. So I'm going to say my num1 here and my num2 here. And I'm going to put the result, int result, in this one. Now, let me get rid of that. Let me comment that, because we don't want to define result twice. And then, of course, I can print if the value, the result value, is %d \n result. We can do that. So here, the difference is instead of excuse me, instead of passing numbers, I'm passing variables, and those variables contain numbers. So that's okay. So 20 plus 50, that's going to be 70, and that's what's going to be printed. And let me get rid of this. Actually, let me keep this. Maybe that'll help. So it says num1 is going to be 20, num2 is going to be 50. Of course, the result is going to be 70. Do you have any questions about this? All right, so let's do another example. Here, I'm going to say void add 5. And let me just say add number 5. And let me say int num. So this function, I'm going to just write some documentation here, is going to add 5 to num. That's it. So it's going to say num equals to num plus 5. It's going to add 5 to num. And what I'm going to do here is I'm going to say int my num in main is going to be, say, 10. And then I'm going to say add number 5. And then I'm going to pass my num in main. And then I'm going to print the value of my num in main is %d \n comma my num in main. So let me pause here and let you, I'm gonna give you some time to think about this. Let me copy this, let me paste it here. I'm gonna give you some time to think about this, and then we can discuss the result. So what's happening here is I'm defining a variable, a num, and then I'm printing it. I'm saying, print the value of my num in main. And then I'm calling add number 5, which is going to be sending this variable to num, and then I'm going to be adding 5 to num and changing it. And then I'm going to be printing my num in main, which is, of course, the one that's here. Let me just tell you that I cannot print num. That's not allowed because num is only defined in this function. And the variables that are defined in functions have that function as a scope. So variables have scope, meaning that essentially a block that you can access the variable in. And if num is defined here as a parameter, that means you can access it only in this function. So I can't print num, but I can print, of course, my num in main because that's been defined here. So before I hit play, what do you think the output is going to be for this code? Well, it's going to be two numbers because I'm printing here and I'm printing here. So what are the two numbers? Okay. So Katie, you're saying 10 for both. Grace, you're saying 10 for both. That's actually correct. It will be 10 for both. And I think, let me explain it to you, although maybe it seems that you have a very good idea of what's happening. But let me still explain it because for the other students that are watching this video, maybe they're not sure why it's going to print 10 for both. But let me hit play and let me at least show you that you are right. It's going to print 10 in both cases. So let me explain to you how that is. And again, you probably maybe kind of know what's happening because you did answer correctly. Let me copy this and paste it. And let me change the cell, or rather, yeah, the cell to say no fill. And let me unmerge. And let me get rid of the text. Okay. So what's happening here is when you do this, there's going to be a variable that's going to get allocated. It's called my num in main. So I'm going to just pick 4 bytes, 1, 2, 3, 4. And this one is my num in main, which actually contains the value 10. Let me make this black. Let me actually even change the color of it. Yeah. So my num in main is here, and it has the value 10. What happens when you call this function and you pass my num in main, you're actually going to make a copy of the value and you're going to assign it to another variable with the name num. So when you call this function, as soon as you call this function, you're essentially saying there's another variable called num, and I want num to be equal to the value of my num in main. So num, which might live here, for example, I'm going to make this like that. Num is going to be 10 right now. Now we're going to go inside the function. We're going to execute this one, and that's going to make num 15. So num is going to become 15. But notice that I didn't change my num in main. That hasn't been changed because I made a copy of it. So of course, when I print the value of my num in main is my num in main, it'll still be 10 because I didn't change that. I only changed num. All right. Do you have any questions about this? Okay. Now I have a question for you, and this is a difficult question. The question that I have for you here is there a way to make this function, add number 5, change this value that I'm sending? So I'd like to change this function so that when I send something to it, it kind of changes my num in main. First, let's kind of discuss this kind of, let's try to together find a solution to this. Let me see. I do see some answers. Let me see. Okay, so Katie and Grace, you're suggesting that we make this one return num, right? We make this one return num, like return num. And of course, we make this an int. And you're saying here, I would say my num in main is equal to this. Okay, I love it. This is great. This is very good answer. This is kind of exactly, this one is going to achieve exactly what I asked for. But I do want to add to my request that I want to keep this void. Okay, so let me keep this because this is really nice. I'm going to keep it like this. I'm going to create void. I'm going to say add 5, add number 5. And I'm going to say no return. And maybe I'm going to do num for now. By the way, you can use the same name because this num is for this scope and this num is for this scope. So you can do that. And I'd like to, I don't want to use this one, my num in main equals to this. So what you proposed is going to work. Let me just actually trace it, make sure that everybody understands that this is going to work, and then we can talk about using this. So this one will work because when you call add number 5 and you're sending the value 10, 10 is going to be stored in num. You're going to add 5 to num. You're going to end up with 15. You're going to return 15, which means this function call, this highlighted section is going to be 15. And you're going to replace the 10 with 15 here. And that's going to work. That's going to print 10, 15. So you can see it printed 10, 15. So that's great. Now, what I'm asking for is for us to call add number 5, no return. And you're allowed to change what you're sending here. So let me tell you what you're allowed to do. You're allowed to change the argument. This is the argument. You're allowed to change the parameter in the function. The parameter in the function is this. And you're allowed to change the body of the function. So this is the body of the function. However, you're not allowed to change the return data type. So you should keep it a void. Yeah, let's do that. What do you think about this? This is going to be tricky a little bit, right? So the problem is when you call a function, you're going to make a copy of the value. So you're going to make a copy of the value. So my first question to you is, what is something that we can send, even though it's going to make a copy of it, that's going to help us access this variable? So imagine, like, what is one number that you can place here that I can use to change this one? Exactly. So Katie's saying a pointer. That's exactly right. So if, let me actually remove some of those. Okay. So I know that the address of this one is 8, right? So 0, 1, 2, 3, 4, 5, 6, 7, and there's an 8. So if this variable contains the value 8, then what this variable could do, of course, it would have to be a pointer, because if you want to put the address of a variable in something, that something has to be a pointer. So it has to be actually 8 bytes, not 4 bytes. So maybe, let me actually do that now. Let me merge first. Yeah, that's good. So this, which I shouldn't call num, I should give it something else. Let's say, for example, let's just say P1. So P1 is going to contain 8, which is really the address of this. And if I have the address of this, what I can do is I can dereference. And remember, dereferencing is going to get me the thing that I'm pointing at. And I can actually change it. This is something that we haven't done. We probably should have, but you shouldn't be too surprised that we can change it. So when you dereference it, it's almost like you have access to the variable. You can get the value, you can print it, and you can also change it. So let's change the code so that we're sending the address. So here in my function, I don't want to send my num in main. I want to send the address of my num in main, right? So in this case, it would be kind of 8. That's what I want to send. I want to send the address of my num in main, which is 8. Now, of course, because it's an address of a variable, this would have to live in a pointer that points to an int. So you cannot have a num here. You can't have an int num here. It would have to be a pointer that points to an int. So you'd have to do something that looks like this. That's a pointer that points to an int. And I would say let's change the name of it. We don't have to change the name of it, but we probably should. So right now, you're sending the address of the variable, and that address is being stored in P1, the pointer P1. Now, of course, you can print P1. You can print if the address of the variable that you're sending, that you're passing, is %p \d, rather \n, comma, P1. You can do that. Of course, we're going to do something else, but for now, let's just print it, make sure that, okay, you can see that here it printed the address of the variable that you're passing is this. This is really the same thing as the address of this. Let me comment this one for a second. So if you want to get the thing that lives at this address, you want to dereference. So every time you do this dereferencing P1, you're essentially talking, let's say, referring to the variable you passed. In this case, of course, it's going to be my num in main. So what we'd like to do is we'd like to do this. My num in main equals to my num in main plus 5. Now, we're not allowed to do this. Why are we not allowed? Because my num in main is defined here. It's a different scope. So we cannot do this. However, we have P1, and P1 contains the address of my num in main. And I know that I can dereference that address. And I know that every time I dereference this address, essentially I'm referring to the variable that I'm passing, which is my num in main. So instead of doing this, which is not allowed, this is not allowed. what I would do is let's dereference P1, and that's going to give me my num in main, because dereferencing P1 is going to be the thing that P1 is pointing at. So I'm talking about those 4 bytes right now. When I do this, I'm talking about those 4 bytes. So I want those 4 bytes to be equal to those 4 bytes plus 5. So if I print my num in main before, and if I print my num in main after, let me actually put this, all of that next to each other. And let me hit return here. You will see that it's going to print 10. This one's going to print 10. And this one's going to print 15. Of course, we don't need to print this one. Let me actually get rid of that line. So you can see here, I was able to change my num in main from another function. And the only way that I was able to do that is by essentially sending the address of that variable and having this function dereference that address, which gives us, again, the 4 bytes that this pointer is pointing at. Let me pause here for a few seconds, see if you have any questions. All right. So this is perfect. It seems that you understand what's happening here. The only way, again, the only way for a function to change the value of a variable that's been defined outside of that scope, the scope would be to use the address and use dereferencing. And that's one way to do it. Now, we're going to talk about arrays right now, and you're going to see how all of that is connected. So right now, functions, arrays, pointers are going to all, come together, and hopefully they will make perfect sense. So let me stop the recording and start a new one.